Now we are going to start with the acid, base and salts. As I've told you that see, every chemical substance has got a certain chemical nature. That means either it is acidic or it is basic or it is you can say neutral in nature. These are the three basic nature which any chemical substance possess. That is the acid, either it acts as acid or it acts as base or it is neutral in nature. So in this chapter what we are going to do, we are going to study in detail about the acids. That means what are the how we can identify the acids, what are the types of acids, or what do we get to have when we react acid with the certain substances. So we are just going to learn about the same things for an acid, same things for bases, and also for the neutral, that like what are their activities. Like we know that the pH is 7, but how they behave in different situations. So before we start the acid, base and salts, what we'll be doing, we'll be starting the individual topic. That means we'll be starting the acid first, the base then the neutral substance, that is the salt, and then we'll be clubbing their differences. So now I'm just going to start with the acids, right? So when we study an acid in detail, or you can say there are certain characteristics which an acid possess, though those characteristics are not so appropriate, but still in the early times the people used to say that acids are those which are sour in taste. That means suppose you have a lemon, right? If you just have a sip of the juice present in it, what you will feel? You will feel the sour taste, right? So the sour taste is so according to them, according to the classical theory, it was said that any substance which possess the sour taste are called as acids. So what do we mean by acids? Before I'm just talking about the early times. Nowadays we have different types of theories which are related to the acids. So these points which I'm just going to sum up here, just indicating the classical theory. That means the points which were obeyed by the early chemists. So they said any substance which are sour in taste, that indicates that it is an acid, right? What other characteristics, what do we get to know about acid? Like the early chemists, what they think, they thought that the substance which are sour in taste are regarded as acid. And the second point was that when these acids react with metal, they liberate the gas which burns with pale blue flame, and if the air is present, it burns with a popping sound. That means they evolve H2 gas. So this is the second property. That means the acid is that substance which when react with metal just produce the hydrogen gas. The third characteristic which were obeyed by the early chemists, it was that if we just add this acid to the litmus, what they are going to do, they are going to turn blue litmus red. So these were the three characteristics which were obeyed by the early chemists in order to distinguish the acid from the bases or acid from the salts. But however, these characteristics are not appropriate, or you can say these characteristics are not sufficient to decide the nature of the substance as an acidic nature. So that means because nowadays, as you know, that the many scientists are daily discovering many things. So that means we have, like till now we have got many theories which just indicate in a proper manner that what characteristics does an acid possess. So we are just going to study that concept. So out of it, like we have got the Arrhenius concept, we have got the Bronsted concept, we have got the Lewis concept, right? Bronsted and Lewis concept you will be doing in the higher standard, that is the +1 standard, but at this moment what we will be doing the Arrhenius concept, and even that concept is able to explain the nature of acid in a proper manner. So just look at the board, what does Arrhenius say, or what is the criteria which is chosen by the Arrhenius to decide the substance as an acid. So actually the Arrhenius was the one who said, who just you can say just provided the information on the chemical nature of the substance by just giving his theory, that is the Arrhenius theory. So what does this theory states for an acid? he said that when any substance when added to water, that means like for him to decide the nature of the substance, there is compulsory that the water should be present, right. So he said that when any substance dissolved in water, if it produce the hydronium ion, or you can say it produce the hydrogen ion, is regarded as an acid. Just look at the board, I'll state you with an example. What does Arrhenius said? He said that suppose we have water in it, water in this beaker, and I add substance X to it. I am adding this X substance to the water. So he said that if this X substance, right, is capable of giving the hydrogen ion in water, that means this given substance is an acid, and if it doesn't give hydrogen ion in water, that means it is not regarded as an acid. So according to the Arrhenius, what is the concept, what is the theory for an acid? It is that any substance when dissolved in water gives the hydrogen ion is called as an acid, right, and any substance which when dissolved in water do not give hydrogen ion, that means it is not regarded as an acid. So that means for the substance to exist as an acid, so the important thing is that it should give hydrogen ion when it is dissolved in water. Now what happens, so it is this is clear to you that you can say the criteria for the substance to exist as acid is that when dissolved in water it should give the hydrogen ion, but you know that this hydrogen ion do not exist in water as hydrogen ion. What does this hydrogen ion do? Actually this hydrogen ion, we know that the structure of the water is this. It has got two covalent bonds with this oxygen is making two covalent bonds with hydrogen, and there are two pairs of lone pair. So when these hydrogen ions are just dissolved in water, they get they just form the coordinate bond between the lone pair, that means between the water molecule and between the hydrogen ion. And I think you know that what is the coordinate bond. Coordinate bond is something in which the bond is like, you know that for the bond to be formed there should be a sharing of electrons. So in this case, in this kind of bond, in this coordinate bond, the shared pair of electron comes from only one atom. So that means one molecule or one atom will be just contributing the whole shared pair, and one will be deficient in the electrons, right. So how, like in this you can see it has got two lone pairs, right. So that means this bond is formed at the cost of sharing of this lone pair of water with this hydrogen ion. See, as I am indicating in the figure. So this is the lone pair, right. So this molecule is just contributing its lone pair to the hydrogen ion, and this type of linkage in which the shared pair comes from the one molecule, right. That means the one has the lone pair and the other is like the link, the other atom to which it is getting linked, atom or an ion, is just deficient of electrons. So that means it is the kind of bond they are forming is a coordinate bond. And this coordinate bond is just this thing expressed in by just putting the arrow. This arrow is just indicating that this lone pair is shared by this lone pair belongs to this, but this molecule is sharing its lone pair with this hydrogen ion. So this is how you can like what happens when hydrogen ion is dissolved in water. So it do not remain this thing as hydrogen ion, so it becomes the hydronium ion because it combines with water, so it forms the hydronium ion. So we can just modify this Arrhenius theory of for an acid as any substance when dissolved in water produce hydronium ion is said to be an acid. Now you know that from where this hydronium word came. Actually the substance when dissolved in water, it gave hydrogen ion, right. That hydrogen ion combines with the the water molecule by a coordinate bond and just linking to form this hydronium ion. So you will just modify it. So instead of writing the hydrogen ion, you will be writing the hydronium ion. It will be an appropriate definition to add to an Arrhenius theory for acid, right. So how you will be stating? You will be stating that when any substance when dissolved in water, if it gives the hydronium ion, then it is regarded as an acid, and if it do not produce hydronium ion, then it is not regarded as acid, right. So this is the Arrhenius theory for an acid, or you can say a theory which state that which show that this substance exists as an acid. Now, I just want you to know that like we have many substances which are existing in nature. So, how you are going to just know that this is an acid or this is not an acid? So, you know the criteria that when any substance dissolved in water just giving rise to hydronium ion is indicated as acid. Now, we have different types of acids. We have different types of acid. Now, the different types of acid on the basis of sources we are doing, like we get an acid from different sources. So, just depending upon the sources like from which we are getting the acids are categorized into two categories. So, what are those two categories? They are organic acids and they are inorganic acids. So, that means we have got two categories. One is organic acid, another is inorganic acid, depending upon the source from which we are getting an acid. Now, what do under organic, which acids are called as organic acids? Those acids which are obtained from plants and animals, either directly or indirectly, they are called as the organic acids. And the acids which are obtained from the minerals present in earth, they are called as inorganic acids. So, that means the acid which we get from plants and animals are called as organic acid, and the acids which we get from the minerals which are present in earth, they are called as inorganic acids. So, just look for the examples. I will just state an example, many examples here. So, when we talk about organic acids, so you know that we get these acids from plants or animals, right? So, some you know that the vinegar which you are using in your kitchen is also acidic in nature, because it contains which acid? It contains the acetic acid, right? The apples you are eating are also acidic in nature, they also contain an acid. And what is the acid which is present in them? It is the malic acid. Again, the olive oil, you must be familiar with the olive oil. It is said to be a good oil for the healthy growth of hair, right? You know that the the olive oil also contain an acid, that is the oleic acid, right? And all citrus fruits, fruits means all fruits that taste sour in nature, they are also acidic. And which acid they contain? Like all citrus fruits means all sour fruits or juicy fruits, and the juice tastes sour in nature, they all contain the citric acids. So, that means we have many acids which we can obtain from the plants and animals, and those acids which we obtain from plants and animals are just regarded as an organic acid. Now, when we come to inorganic acids, so inorganic acids are those which are found or which are present or which are obtained from the minerals that are present in the earth crust. So, what are those acids? So, we have many inorganic acids, out of which the main acids are sulfuric acid, nitric acid, the hydrochloric acid. These are the important acids, that is the important inorganic acids which are obtained from the minerals of the earth. I will write the formula along. As you all must be familiar, sulfuric acid is H2SO4, nitric acid is HNO3, and hydrochloric acid is HCl. So, that means we have got many inorganic acids, it is clear to you, but out of them these three are very important. That is why I have just listed their name, but it is not limited to only three, we have got a list of inorganic acids. So, these on the basis of sources, we just divide the acid into two categories, the organic and the inorganic one. But this classification is not limited to the one classification, we have many other classifications. So, just look at the board. Now, we are classifying on the basis of water content they have. right? That means we are just classifying the acids into two categories depending upon whether they contain the water content or whether they don't contain the water content. So you should know that all acids have that water content, but the difference is that in some acids the water content is more and in some acids the water content is low. So just look at the board that on the basis of more or high, the high or less water content, they are categorized under two categories. And those two categories are dilute and concentrated acid, right? So if the dilute acid is that which contains the higher amount of water in it, or you can say which contain lower proportion of the concentration in it. That means there is more amount of water but less amount of salt concentration. So that means that is called as in dilute acid. So dilute acid is that which has the lower water content. Water content lower. And concentrated is that which has, again I will be repeating, I will just confused with two things, that is the water and the solution. Again I will repeat that for you. So see, on the basis of water content we have two kind of solutions, one is dilute and other is concentrated. If the water content is high, that means I will just write high. So that means the water content is more and the concentration of the salt in its aqueous solution is less. So that means it is called as dilute solution and dilute acid. And if the water content is low and the concentration is high in its dilute solution, then it is called as concentrated acid. So like we have hydrochloric acid, we have sulfuric acid, we have nitric acid. So it is our wish that we can make the nitric acid as in dilute nitric acid, or we make it as the nitric acid as the concentrated acid. It is just a matter of water content, or it is just a matter of the concentration of the solute in its aqueous solution, right? So it is not specified that the hydrochloric acid exists as only dilute acid or hydrochloric acid exists as only concentrated acid. See, any acid can be made dilute or any acid can be made concentrated. It is our wish that what percentage of acid, the salt, and what percentage of water we are just using to make an acid. So any acid can be act as dilute or any acid can act as concentrated, just based on the amount which we are using, the amount of the water and the amount of the concentration which we are using to make an acid. So, but you get a question based on it, that you get a question like how one can dilute concentrated acid. That means we have got concentrated acid and I just want to dilute it. If somebody asks you that how one can dilute concentrated acid, so you will answer in a way like concentrated acid, that means it has less amount of water. And what is the question like? Ma'am, you said you want to dilute it, so you will say that ma'am, just add water to the concentrated acid and your acid will get diluted. But it is not like that. So you should know that we cannot pour water directly into the concentrated acid. The reason being the reaction between the acid and the water is highly exothermic. So what happens? If you will just add the water into the acid, what is going to occur? The enormous amount of energy is going to take place, the evolution of enormous amount of energy which will lead to the explosion, right? So we'll not, it is not simple to dilute concentrated acid, we have to do it carefully. So just look at the board how we are going to dilute the concentrated acid. So what we need to take, I am just taking the beaker, and in beaker I don't have the concentrated acid, I have the dilute, or you can say I have the water. So that means I am not taking the the concentrated acid in a beaker, I am taking the water in the beaker. And what I am going to do, I am just going to add concentrated acid and you we'll be adding concentrated acid to the water, but we can't add concentrated acid in a water with a full flow, right? We need to add it drop wise. So what we do, we add concentrated acid drop wise to a water with continuous stirring. What we are doing, see, I have just taken a, suppose I have a beaker or a glass in which I have water. I am just pouring the acid, but not pouring the acid in a flow. That means we don't need to have like the many acid molecules flowing into the water. We need to make the flow of concentrated acid into water drop wise. Now what is the reason that we are just adding the acid into water drop wise, and even the continuous stirring is needed, right? So what is the reason behind? The reason is that as I told you, the reaction between the concentrated acid and the water is highly exothermic. So when we will add the concentrated acid drop wise into the water, then obviously the energy is going to be, the energy which will be released will be going to be very less, and moreover we are just stirring it. So what happens, what advantage do we get on stirring? That energy which is produced is continuously absorbed by the water molecules because we are stirring it, right? So that means, so it serves a two purpose. One is that the energy release is comparatively low, and second, by stirring we are just you can say distributing the energy to the all water molecules, so that the energy release is not too high and energy release is comparatively less, so that it do not leads to explosion. So if somebody asks you that like if you get a question in your paper that how one can dilute concentrated acid, just write, we can dilute concentrated acid by just pouring the acid drop wise with continuous stirring into the container which contain the water, and we are doing in such a way because so that the energy release should be comparatively less and it should be continuously absorbed by the water molecules in order to avoid the explosion, as we know that the reaction is highly exothermic in nature. So this is how you are going to answer if you get a question that how one can dilute the concentrated acid. Now we have see the classification is not limited to the two. We have the other type of classification as well, and that classification is on the basis of strength of an acid. So on the basis of strength of an acid, we have got two types of acids. One is strong acid and other is weak acid, right? But before you you learn the strength of acid, I would like to make you familiar with one term. That term is degree of dissociation. As I told you, when we add acid to the water, it produces the hydrogen ions. That means that when we add acid to the water, it is getting ionized. That is clear to you. Now what happened? So what does this degree of dissociation actually, or degree of dissociation, or you can say the degree of ionization. What does this degree of dissociation or ionization terms indicate? It indicates the number of ions which actually get produced when acid is dissolved in water. I am repeating, it actually indicates the number of ions that are produced when acid is dissolved in water. So this degree of dissociation is indicated by alpha. It is a symbol used for the degree of dissociation or the ionization, and it is equal to the number of molecules of acid that get ionized and divided by total number of molecules of acid which we add into 100. So when we apply this kind of formula, we are going to get the value for the alpha, and you know that if the value of the alpha is greater than 30%, then means it is a strong acid. So means we get to have many ions in the water when we are going to add the acid into the water. But if the alpha is less than the 30%, that means it has not got ionized to a greater extent, so we regard that acid as a weak acid. So this is how we are going to differentiate. Now you are just you will be able to do this classification. So strength of acid is the strong acid and the weak acid. So strong acid is that which completely get ionized when it is dissolved in the water. Like suppose I add HX to water, So that means this HX will hold the ionizing into the H positive and the X negative ion. We won't be getting this HX molecule. That means there will be no molecule which remain the unionized, because all the H ions it has already like split to release those H ions. So that in that case it is regarded as a strong acid. And weak acid is something which gets partially dissociate. So that means we will get to see the H ions, we will get to see the X negative ion, and though we will get to see the unionized molecules as well. So that means the strong acid gets completely ionized and the weak acid gets partially ionized. And when we look for the example for it, so see the the inorganic acids are the strong acids and all the organic acids are the weak acids. So this is how we just classify the